Morning, good afternoon, good evening, ninth grade physical science. I hope this keynote presentation that I'm going to be talking through today, I hope it finds you doing well, being successful in your online learning. This is week 3. This is an important week for all of us with physical science, is because with this week, I'm going to be introducing you to waves, wave properties, and light. And this is kind of the direction that we're going to be going really for the remainder of the school year, is focusing on waves, not only light, but then eventually leading into sound. So with this keynote presentation, my goal today is I first want to introduce you to what are electromagnetic waves? What's the electromagnetic spectrum? This is probably going to be review for you. Then what I want to do is I want to go into different wave properties, 2 main wave types, light versus sound. Give you some background information about that, give you some important vocabulary, and then let you go and practice these wave properties with choice notes. So when you're viewing this presentation, what I'm going to be doing is I'll be walking you through the slides. Please pay attention to the diagrams. If you want to, write down notes. I will tell you exactly where everything is in Canvas while we're working through this presentation, because I want to make sure that you have all the tools, again, that you need to be successful as we move forward, trying to make this as painless as possible. Okay, so as we make our way through this keynote presentation, like I said, sit back, listen, follow along. Please feel free to take notes. And I will guide you, like I said, along the way of where you can go in Canvas and get even additional information. So starting off with our introduction of light, what I'm first going to talk about is what are electromagnetic waves. And following the screen in front of you, what are these waves? These are waves that are made by vibrating electric charges. These are waves that can travel through space. And what that means is that they can travel with no matter present. Not a solid, liquid, or gas needs to be present for these electromagnetic waves to travel through. These are very, very unique waves. How do these electromagnetic waves form? These waves form when you have an electron. And remember, whenever you have a vibrating electron, you have a magnetic field. So when that electron vibrates with these waves, they're moving and they're creating a magnetic field. And when that magnetic field keeps moving, what is it doing? It's also inducing another electric field. And so how these electromagnetic waves form is you basically have magnetic fields and electric fields that are moving perpendicular to one another, and they keep changing. And it's what these moving, vibrating electric and magnetic fields create is how they get to the electromagnetic waves. So just take a look at that diagram that I have in front of you. The blue would be the moving magnetic field. That moving magnetic field is perpendicular to that moving electric field. And that moving, again, electric and magnetic fields is what is generating the electromagnetic waves. Waves that can travel through space with no matter present. What are some properties of electromagnetic waves? Well, these are waves that can travel outward in all directions. All you need is to have that one source, and these waves will move outward from that source. What energy do electromagnetic waves transfer? They transfer, probably what you're most familiar with, is light energy. Light energy is what is carried by these electromagnetic waves. The wave speed of these electromagnetic waves can vary, and it varies depending upon what medium, what type of matter they are traveling in. For example, in a vacuum, no matter present in space, light has a speed of 300,000 kilometers per second. But take a look at what happens when those electromagnetic waves move through a liquid, something a little bit less dense. The light speed decreases to 226,000 kilometers per second. And we're going to talk about in a couple weeks how the difference in that wave speed also leads to a pretty a phenomenon with light that you all know, and that's refraction, the bending of light. Why, when you stick a straw into a glass of water, does it look like it's chopped in half? It's because of the changing speed of light through those different mediums. So that's just kind of a prelude of what's coming. Another property of electromagnetic waves is that they are a type of wave called a transverse wave. And when we move further through this presentation, I will tell you exactly what a transverse wave is. But just kind of keep in your mind, electromagnetic waves are transverse waves. Okay, with these electromagnetic waves, all of these electromagnetic waves are a part of the electromagnetic spectrum. And you see that diagram on this screen. I know you have seen the electromagnetic spectrum before and have probably talked about each of these different types. So the electromagnetic spectrum is basically the full range of electromagnetic radiation with different wavelengths and frequencies. And if we take a closer look at that electromagnetic spectrum, you can see how the wavelengths and the frequencies change as you make your way across that spectrum. Starting on the left-hand side, we've got our radio waves, very low frequency, very long wavelengths. But then take a look at what happens when we move to the right, when we move from radio to microwaves, to infrared, to light, ultraviolet, X-rays, gamma rays. You can see that we move from a low frequency wave to a very high frequency wave. We move from a very long wavelength to a very short wavelength. And next week, you are going to do a PhET simulation, kind of finding what that relationship is between frequency and wavelength and having a little bit of a closer look at that. Okay, now on this screen, you're going to see in that lower left corner, I've got a video link. That's my reminder that you've got a video coming up that I'm going to have you watch. So what I would like you to do is when you see the stop sign, okay, you're going to head over to Canvas. If you go to our modules for physical science, and you go to our unexpected school closure online learning, you're going to see that I now have published assignments for April 13th through the 17th, okay? Underneath those assignments, you're going to find an electromagnetic spectrum video guide and an electromagnetic spectrum video. What I would like you to do for your first weekly assignment, okay, is you are going to view the electromagnetic spectrum video. I believe it's like roughly 32 minutes long. While you are viewing that video, I want you to fill out the electromagnetic spectrum video guide. What you're going to do is you're going to write a brief description of all the different types of electromagnetic radiation in the electromagnetic spectrum. You're also going to write down some uses and some application for those different types of radiation. And so while you're viewing, like I said, you are going to take notes, and then this is going to be your first weekly assignment. You are going to submit into Canvas a picture of your typed or written version of that video guide. All right? That video guide is going to be due in Canvas by 3 p.m. on Friday, April 17th. Okay, so whether you type or you write, you're going to take a quick picture and you're going to file upload. All right, so on this screen, this is the stop. While you're watching this video, this is where I want you to stop, head over to Canvas. I want you to get that video on the electromagnetic spectrum up and running. I want you to either print off a copy of the guide or you can save a copy of that Google Doc, type right on it. You're going to fill that in as you go along viewing that video. Again, fill in the description, fill in uses and applications, and once you're done, you can submit that into Canvas right away. Okay, but it is due on Friday, April 17th by 3 p.m. Okay, I'm going to have a little bit of a pause here, and then once you're done viewing that video, completing that guide, this is where you are going to pick up with our keynote presentation. I'm going to take you into different wave properties, all right, and get you into your second weekly assignment.